Hello and welcome to the section 8.2 lecture today for Algebra 1 Part 2. Today we're going to be looking at solving one variable inequalities. So we kind of worked last time with graphing them, and in this section we're going to be solving and then graphing. So for the most of it, I guess most of the time, we're solving the same steps as we would when we're solving equations. So here I'm going to subtract 3 from both sides. And I'm actually going to leave x where it's at. 8 minus 3 is 5. And it says that 5 is less than or equal to x. Now, one thing that a lot of people like to do is to rewrite this as x is greater than or equal to 5. Okay, it's just very helpful because that way when we read it, we can tell that we're going to need 0. 1, 2, 3, 4, 5. 5 being right there. Greater than or equal to is a filled in circle, and we're shading to the right. And there we go. On the next one, same process. Add 7 to both sides. We're going to get x is greater than, that's going to be 22. And so really all I need to know is let's put 0 there. And if you want to come up with a good layout of what we have here, you can count out and make some scale that gets you to 22. And so for this one, since it's just greater than, it's going to be an open circle on 22 and shaded to the right. Okay. The next ones that we have, on this one we have x divided by 3, so we multiply by 3 on both sides. And we get x is greater than or equal to, seeming like we get a lot of greater thans. That's going to be negative 36. So I need to know where 0 is, and let's call negative 36 right there. We want a filled in circle for the or equal to, and shade it to the right. On this last one, I'm going to take 7 and divide by 7 on both sides, and I'm going to get x is less than, let's see, is this thing working? No. There we go. And 96 divided by 7 gives me 28. I guess I had a calculator on my computer, but wasn't thinking straight. So for this one, we need where 0 is and tell me where 28 is. I'm not too picky about the scale. That's going to be an open circle because there is no or equal to, and then shaded to the left. That's where the smaller numbers live, is out here to the left. All right, next one. Negative 4x is less than 36. Now, I'm not going to go too deep into this, but if I divide by negative 4 on both sides, I'm going to get x is, right now it says less than or equal to negative 9. Okay, now there's a problem with that. Because I divided by a negative, and I can show it this way. Let's go ahead and let's take the same thing. I said I didn't want to go too deep into this, but I guess I am. I'm going to add 4x to both sides, which is weird. I'm going to add 4x to both sides. So I get 0 is less than 36 plus 4x. And then I'm going to subtract 36 on both sides. And if all is right, doing it this way, I should get the same answer. I get negative 36 is less than 4x, which if I solve that, if I divide by 4 on both sides, I should get negative 9 is less than x. Now that's different than what this says, because if I flip this around, this would be x is greater than, just greater than negative 9. So I have conflicting results here. And what it comes down to is that whenever I multiply or divide by a negative, I have to flip the inequality. All right, the right answer is x is greater than negative 9. So let's call negative 9 there and 0 there. Open circle at negative 9, and I'm looking for the numbers that are bigger. All right. Same thing on this one. I'm multiplying by negative 11. Multiply by negative 11. So I am going to have to flip the inequality. And it's going to give me negative 77 as a number. Tell me where that is. Tell me where 0 is. Filled in circle and numbers that are smaller. Okay. So the rule that we want to follow is, and I'm actually going to type it so it looks a little bit better. But whenever we multiply or divide by a negative, we have to flip the inequality. So whenever we multiply or divide by a negative number, when we're in the process of solving it, we want to flip the inequality. We have to. That's a need. Okay, there is no it's a good idea or anything like that. It's a requirement. Okay, so go ahead and pause the video and give these three a shot. Keep this rule in mind if it comes up. Hopefully I had a chance to do that. On the first one, we multiply by multiply by 4, not a negative 4. So I do not flip the inequality. The only other time that I kind of flip the inequality is if I write this the other way. Okay, but that's not really the same act of flipping the inequality. I'm just leaving the order of the inequality intact by doing it this way. So we'll call negative 36 down here, 0 up here. I'm not too picky on these ones, at least about any kind of a scale. You can spend a little more time if you'd like to get, let's call them all 3s or call them all 4s, and you can get there. Negative 4, negative 8, negative 12, and so on. So that can be something that you can do. I'm going to focus on just getting the inequalities down and mainly focusing on solving. On the next one, we're subtracting 7 on both sides. Hopefully you had a good experience with that. We just get x is greater than 2. So if we've got 0 there and we've got 2 there, we're looking for numbers that are bigger than 2, but not including 2. So we leave it as an open circle and shade to the right. On the last one here, I'm dividing by negative 11. Whoa, ding, 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 ding. Divide by negative 11. Right? I tell myself what I'm doing to solve. That way if one of these rules do come up, I kind of highlight my own brain to it a little bit. So I am dividing by a negative, so that means I'm going to flip the inequality. So it's going that way now. And this is just going to be 10. Now, if I want to write this in a better way, I always think of just a mirror right here. And I'm flipping these things over the mirror. So that means the k goes first. The inequality, like the mirror image, would point at the k. And the other side would be 10. Not 0, 1, that the true mirror image would be. Not focused on that. Let's put 10 there, 0 there. Fill in the circle because it has an or equal to. And shading to the left. And there we go. Let's go ahead and turn the page. On these ones, we're looking at multi-step inequalities. So we have multiple things happening to the variable, and we want to undo them just like we would solving equations. So let's jump right into it. All right, I've got 4v, I got negative 1 plus 4v, or 4v minus 1, however you want to look at that. I'm going to go ahead and add 1 to both sides. That's going to give me negative 80. And 4v there. If I divide by 4, I don't have to use that rule. I just divided by 4. I get negative 20. Oh, that's just going to be a v now. Great v. Good job. Now flip it around if you want to. V is going to be less than or equal to negative 20. Let's call 0 there, negative 20 way over here. Fill in the circle because it could be negative 20. And shade to the left. where the smaller numbers live. Next one here, we've got k divided by negative 5 minus 6 equals negative 6. Let's go ahead and add 6 to both sides. And I'll have k divided by negative 5 greater than or equal to, that's going to be 0. Okay. And then I want to multiply by negative 5. Whoa. Multiply by negative 5. That means I need to flip the inequality. Even though it's not going to change this side at all because a 0 times anything is 0, I still have to flip that inequality. So I need to know where 0 is. That looks like a closed-in circle and shaded to the left. And I'm not necessarily purposely being very messy with my shading, just trying not to take too much time. The next one, the first thing I have to do is multiply by 5, right? Because there's those unwritten parentheses around this, so we're going to deal with that part last. Now I have 10 plus x is less than 15. Multiplied by 5, nothing weird happened. Subtract 10, nothing weird happens when I add or subtract. And so I'm going to get x is less than 5. Tell me where 0 is. We can be nice. 1, 2, 3, 4, 5. Got to know where 5 is. Open circle because it's less than. And finding numbers smaller than 5 this way. Okay. We got the last 3. Not expecting us to graph these. Just trying to get them solved. So let's go ahead and do that. On the first one, take your pick on what you want to do. I'm actually going to divide it by 4 first. I think that's going to make life a little bit easier, and it is an option, right? The other option would be distribute. But if I don't distribute, now I just have m minus 7, and this is pretty quick and painless to add 7 to both sides. I get 5 is greater than m, or we can say m is less than 5. Either one of those would be okay. On the next one here, I've got to distribute because I've got to combine like terms, it looks like. So I'm going to rewrite this part, rewrite the 8n, distribute, and there we go. Now I've got negative 125 is less than 15n minus 35. If I add 35 to both sides, this left side is going to become negative 90, and that's going to be less than 15n. Just double check. 90 divided by 15. No, there needs to be a negative in there, and I get negative 6. So over here we get negative 6, so I just divided by 15 on both sides. I get negative 6 is less than n, or n is greater than negative 6. Both those things mean the same thing. Next set over here, I can either, it's probably not a bad idea. I've got a couple options of how to do this. I'm going to distribute and combine like terms first. It might make it a little bit ugly, but it should work out in the end. This is going to give me negative 24x. That's going to give me negative 48. Plus 5 is greater than negative 91. So here I get negative 24x minus 43 and is greater than negative 91. We'll go ahead and add 43 to both sides. And with any amount of luck, that's going to turn into something nice. Yeah, I think it does, negative 48. So negative 24x is greater than negative 48. Divide both sides by negative 24. Divide by negative 24 means I need to flip the inequality, but I get less than 2. Okay, and that's my answer. Okay, so keep that one rule in mind. Otherwise, this is really just another way to solve equations, or another look at solving equations. Anyways, I hope you have a great day, and we will see you in class.